Hello, my dear students. It's my pleasure to meet you today. I am Mr. Abdul Nasser Gaiber and my colleagues here in Studio 12 in our educational national channel. Today, inshallah, we are going to study in the new trig lesson. Please concentrate with me because we are going to study a new system, and the lesson of today is systems of measuring angles. Okay, look here. If we have a circle like that, okay, we know that this line segment AB is the diameter, okay, and we have the semicircle here. If we start from here, say 0 degree, we'll complete as 10, 20, 30 degrees. What about degrees? Now we have the first system which we already study here from the first studying of primary schools. We have here, this is protractor. If we try to draw this semicircle here, okay, and this is half or semicircle like that, and we know that this protractor measures an angle and start from 0 here, 1 degree, 2, 3, 5 and so on until 10, then 20, okay, 0, 10, 20, 30 and so on until 90, then 100 and so on until we reach 180, because the semicircle here, its measure is 180 degrees. And we can start from this side 0, 10, 20, 30, 40 and so on until we reach 180. This is just the first system that we already study in our starting schools. We called it degree system measure or degree measure system. Degree measure system. We know about degree measure system. If we have an angle here, we have a ray, and we will try to draw an angle of 60 degrees as example. Then we count 0, 10, 20, 30, 40 until 60 here, and we complete another ray. This angle will be 60 degrees. Okay, this is a degree measure system, and we will study some about degree measure system now. The 1 degree here equal how many parts? We know, my dear students, that here 0, 1, 2, 3, 4, 5 and so on until 10. Okay, what's the meaning of that? That means that we have small arcs 1, 2, 3 and so on until 10. Okay, each arc represents 1 degree. We divide each degree into 60 equal parts or 60 equal arcs called minute, and each minute is divided into 60 equal parts called second, like our hour. Okay, so we have the degree measure system already. We use it from studying of primary studying. Okay, What about 1 degree equals 60 minutes and 1 minute equals 60 seconds? If we have half degree equals how many minutes? Of course, because 1 degree equals 60 minutes, then half degree equal 30 minutes. And quarter degree equal 15 minutes, and so on. Okay? Let's go to some examples about how we can convert from a degree to minutes, seconds, and vice versa. If we have 2.5 degree and we want to convert it to degrees, minutes, and seconds, we know that 2 degrees, 2 multiplied by 60 equals 120 minutes, and we have half here. The half is 30. 30 plus 120 equals 150 minutes. Okay? And if we have 3.25 degrees and you would convert it to degrees, minutes, and seconds, we will convert the quarter here. It will be 3 degrees and 15 minutes. Okay? And we know that if we have another example, if we have 37 and 3/8 degrees, and we would like to convert it to degrees, minutes, and seconds, we can use calculator here. Here we have a calculator. You can start writing 37 and 3/8 equals, we can put here degrees. We will have 37 degrees, 22 minutes, and 30 seconds. Okay, we just write 37 and 3/8 degrees here, and we press on the button degrees here. You see it. So we can convert using calculator 37 and 3/8 degrees into degrees, minutes, and seconds by pressing these buttons in the calculator. Okay? And if vice versa, to convert these degrees, minutes, seconds, we just write them here as, if we have 37 degrees, 22 minutes, and 30 seconds, we will convert it to degrees only. We can press in the calculator 37 degrees and 22 minutes. Minutes here, you press degrees here, but the calculator understands that you mean minutes. And 30 seconds, you press the same button here, and you write equal. You press here in degrees. You will find that it's 37.375, or you can write it as this one, or shift SD, you will write it as a mixed number, which is 37 and 3/8 degrees. Okay, this is the degree measure system. And now, my dear students, we are going to study new system of measuring angles, which we call it Radian measure system. Radian measure system. Okay, let's write it here. Number 2, Radian measure system. what is the radian measure system? Let's draw a circle or many circles, many concentric circles like that. If we have small circle, then it will be bigger circle, have the same circle, same center, another bigger circle, and let's draw the last one, the biggest one. Okay, here is the center. Look carefully, I have a circle here and another one has the same center, and the bigger one have the same center also. So they are concentric circles, and the last one here. Okay, we know that this is the center of circle, we call it M, and if we draw a ray like that passing through all circles and another one like that, okay, and say this point A1, A2, A3, A4, and this point we called it B1, B2, B3, B4. We know that this is the center of circle, and this is the central angle here. Okay, so what the radian measure system, if we divide the length of A1 B1, the arc A1 B1, this arc, if we divide it by the radius of first circle, which is MA1, and we divide the length of A2 B2, okay, A2 B2 here, over MA2, which is the radius of second circle, this circle, and if we divide also A3 B3 over M A3, if we divide all these, we will find that this number equals this number equals this number, so it's constant number for all these circles. Okay, this arc, if we divide it by this radius, and this arc divided by this radius, and this arc in the third circle divided by its radius, and this arc divided by this radius, we will find the result for all these circles are constant number. This constant number called theta rad. What is the theta rad? Theta rad is the central angle here, the measure of central angle, but in radian measure. So to get the radian measure, okay, we just divide the length of the arc divided by the radius of the circle. Okay, so we have the theta rad, or theta, which is the central angle measured by radian system. Okay, so we will do this now. A rule, we can use it, that theta rad all the time can be find by dividing the length of the arc here by its radius. Okay, this arc divided by this radius equals theta rad, and this arc divided by this radius equals the same central angle theta rad, and so on. So we can consider it as a rule here, and we already deduce it. And for to be easy for you, you can write a magic triangle like that. You can put here L and R, here theta rad. Okay, to find theta rad, you must divide L over R, and to find L, you multiply theta rad by R, and to find R, which is the radius, you have to divide length over theta rad. Okay, so keep it L, here is L, theta rad, and the radius. Okay, so it's the definition of theta rad or radian system here, to divide the length of the arc over the radius all the time. Let's talk, my dear students, about the unit of the radian measure. We know that the unit of measuring system degree measure is the degree, and we know that we divide the circle into 360 equal arcs, so each arc represents degree. But now let's move to the radian measure system. What it's a unit? Okay, let's draw a circle here. This is the center M, and the circle like that, to be clear to you. Okay, and we have radius here and another radius here. We know that the radii of the circle are equal in length, and if we have the length of the arc here is equal to the radius of the circle, concentrate carefully, we have the radii are equal in length, and if the length of the arc are equal to the radius, and we know that theta rad equals L, which is the length of the arc over the length of radius, and we know that the L here equal R, so it's 1 what? 1 radian unit. So we will have a unit of the radian measure by using this rule, which is we have 2 radii here, and of course they are equal. If the radius circle equals the length of the arc, so L over R equal R over R equal 1. So the unit of measuring theta rad is 1 rad, and in the condition of equality of L to R. Okay, let's move to another definition. We will deal with something called a unit circle. What is a unit circle? It's very important for studying trig this year. The unit circle, if we have a circle and its radius is unit, its radius unit means if the radius 1 centimeter or 1 meter or 1 millimeter or even 1 kilometer, it will be the unit of length. So here we have a circle and its radius equals 1 centimeter, 1 meter, and any one. If we have this circle and its radius equal 1, we call it unit circle. Okay, let's, my dear students, solve some examples here about radian measure to practice how to solve exercises. And the first question or example is if we have a circle like that, which is a circle. Okay, and we have the radii of this circle, this radius and this one, and this is M, this is A, and this point is B, and the length of the radius equal 12 centimeters 12 centimeters here, and the length of the arc equals 8 pi centimeter. Some of you say pi. Yes, what is pi? Fortunately, that pi is the radial measure of angles, and we know pi is irrational number, is an irrational number approximately equal 22/7. My dear students, it's not equal exactly 22/7, but approximately equals 22/7, which is rad measure. Let's here go to pi. If we press shift and x, which is the middle button here, this is pi, and you write put equal SD, you will find 3.14, or shift SD. Okay, you will find it as 22/7. Doesn't write here, but it is equal approximately 3.14 or 22/7. So approximately equal 22/7 or 3.14. Okay, this is pi, which is radian measure. So 8 pi is a radian measure for AB, which is the arc. Okay, the length of the arc here 8 pi, and the radius equal 12, and the request is to find measure angle AMB in radian. Okay, we know from we studying now that we have L is the length of the arc of AB here, L, and we know R here is 12 centimeter, and we want to find theta rad. So to find theta rad, we will divide L over R. L here is 8 pi over the radius, which is 12 centimeter, and theta rad here will be equal 2/3 pi, or approximately equal 2.1 rad. Okay, by the way, rad here we can go with centimeters or meters. So 2.1 rad means this is this arc, okay, or this angle in radian equal about 2.1 centimeter, or you can say 2.1 rad. But about the arc AB here, 8 pi, if we multiplied 8 times pi equals, that means 25.1 centimeter. It's a part of circle. If we expand it, it will be 25.1 centimeter. Okay, my dear students, let's take a little break and we will return again. Hello again, my dear students. We are going to solve another example. So concentrate here. If we have a circle like that, and we have M here, let be MA here, MB, and this is theta rad, which is pi over 2. We will know that pi over 2 means here 90 degrees in measure, in degree measure. So theta rad here equal pi over 2, and we have the length of the arc equal 5 pi centimeter. So the request is to find the length of the radius length of the circle. So r is unknown here. To find r, we divide L by theta rad. So we know L is 5 pi divided by pi over 2. So the radius here will be equal 10 centimeter, because we know that in the magic triangle here is L, theta rad here, and r is here. To find r, we divide L by theta rad. Let's move to another example. We have here another circle like that, and we have the center of circle. We have A, M, and this is B, and we have reflex angle, this reflex angle here, which is equal 5 over 4 pi. Okay, and the radius equal 8 centimeter, and we want to find the major length or major arc here. The length of major arc here. Why is the measure of arc? Because we have two arcs. We have two arcs here. This is a small one which is minor, and this is a big one which is major. Because we have this angle which is reflex angle, it's opposite exactly with the major arc L, or the major arc AB, or we can say ACB. So to find L, we know that to find L here, we multiply theta rad by the radius. Theta rad here is 5 over 4 pi multiplied by the radius, which is 8. Okay, we can calculate it using calculator here. 5 over 4 pi times 8 equals approximately 3.2, approximately 3.2 centimeters. Okay, and if you want to find the minor arc, first we have to subtract this measure angle from 360 degrees if we deal with degree measure, and from 2 pi we know that this protractor here, this semicircle is 180, which is pi, and the remainder here is another 180 degrees or another pi. So the circle in radian measure is 2 pi. Okay, so if we subtract 2 pi from minus 5 over 4 pi, so 2 minus 5 over 4 equals 3 over 4. So the theta rad here equal 5 over 4, 3 over 4, sorry, 3 over 4 pi, and to find L, we will multiply 3 over 4 pi times 8 to find the minor or the small arc here, which is L, or we can say it L1. So 3 over 4 pi times 8 equals 6 pi. Okay, now my dear student, we have know that we know that if we have a central angle in radian measure and a radius, we can get the length of the arc, and we can get the smaller angle in radian, which is 3 over 4 pi, and we multiply by 8, which is the radius, and we will get this arc, which is 6 pi. Okay, let's move to another part of this lesson. I know that radian measure now is very new for you, but it's easy really, and you will find it easy if you study it well. So let's move to what's the relation between radian measure and degree measure. Okay, if we have a circle here like that, and we clarify it. We have a circle, and we have, this is the center of the circle, and we have here a central angle like that. This is A, B. The measure angle of central angle here, we call it x degree. Okay, and if we divide the measure of the arc, the measure of this arc AB here, measure of the arc AB over the measure of the circle or the length of the circle of circle, of course it's equal, this measure of angle will be equal this arc as we studied in the third preparatory. So we can say that the length of the arc AB over the circumference of circle, which is 2 pi r. So we have here the measure of the arc AB over the measure, you can say measure of the vector, measure of the circle, which will be 360 degrees, and the length of the circle of the arc AB, which is L, over 2 pi r. By dividing 2 or cancelling 2 here, divide 2 will be L over pi r, and of course divided 2 will be 180, and measure of arc AB, okay, measure of arc AB is x degrees over 180 equals L over pi r, and if L here equals r, if L equals r here, then we will substitute about L by r, so it will be pi r from the definition of the unit of circle, unit of theta rad, and we will cancel r by r here. Okay, so sorry, we will not cancel L, but still L over pi r here. Okay, so x degrees over 180 degree equal L over pi r, and we will make cross multiplication. We will find that theta rad here equal x degrees multiplied by pi over 180, and if we want to find x degrees, it will be theta rad times 180 over pi. So my dear students, we have deduced that if we want to convert degrees to rad, we will use this rule, theta rad equal x degrees multiplied by pi over 180, And if we want to convert from theta rad to degrees, we will multiply theta rad by 180 over pi. Let's get some examples to practice it. Let's write example number 1 here. If we have a degree measure angle like this, 75 degrees, 32 minutes and 15 seconds, and we want to convert this angle from degrees to rad. So we write theta rad equal x degrees times pi over 180 degrees. X degrees here 75, 32, 15 degrees, minutes and seconds, times pi over 180. You can use your calculator here. You write 75 degrees, 32 minutes and 15 seconds multiplied by pi divided 180 degrees equal 1.3, approximately 1.3 rad. So the answer of this convert approximately 1.3 rad. And we have convert from degrees here to rad. Okay, let's go to another example. If we have theta rad equals 2.38 rad and you want to convert it to degrees, we write the rule x degrees equal theta rad times 180 degrees over pi. And notice that if you want to have degrees, 180 will be up, and if we want to theta rad, the pi is up, okay, because pi is read as theta rad and x degrees is as 180 degrees, and we know that 180 is equivalent to pi because we have said before that the semicircle here as degrees from 0 degree to 180. But here if we measure as rad, it's pi rad, and this half also 180 or pi, so the circle is 2 pi as rad or 360 as degrees. Okay, so we have x degrees here, theta rad equal 2.38 multiplied by 180 over pi. You can use your calculator. 2.38 multiplied by 180 degrees over pi. The answer will be 136.36 degree, or we can convert it to degrees, minutes and seconds by this way. Press this button, which is degrees, equals approximately 130 degrees, 36 degrees, 136 degrees, 21 minutes and about 50 seconds. Okay, let's move to another example. We have many examples to clarify and practice how to solve many exercises. We have here an example. Say determine the quadrant. What is the quadrant? Let's draw the quadrants here. We have here x-axis and y-axis. and we have this axis, which is x-axis, start with 0 degree and move here to have 90 degrees and move to have 180 degrees and move also to have 270 degrees and to move to have 360 degrees here, this line. So from 0 to 90, or between 0 and 90, it will be the first quadrant. And from 90, or between 90 and 180, is the second quadrant. Between 180 to 270 is the third quadrant, and between 270 and 360 is the fourth quadrant. So we have 4 equal parts here, or 4 quadrants. This is the first, second, third, and fourth. Okay, so someone asked us the theta rad here equals 2.02 rad. Where this angle lie in first or second or third or fourth quadrant? First, it's be easy for you to convert it from radian to degrees, like that. Okay, so it's 2.02 rad multiplied by 180 degrees divided by pi, and it is equal approximately 115.7 degrees. When we ask ourselves 115.7, is it lies in the first, second, third, fourth quadrant? Here between 0 and 90, here between 90 and 180, and we know that 115 here is the number between 90 and 180, so it is lie in the second quadrant. And if someone asks us about theta rad equals negative 7.3 rad, what quadrant here lie in? We will use your calculator, but write negative 7.3 multiplied by 180 degrees divided pi. It's equal approximately negative 418.3. Negative 418.3 degrees. We have a problem here. Okay, we have a problem here because it's negative. Just make plus 360, it will be negative also. Make plus another 360, and the answer will be 301.44 degrees, which is lies in the fourth quadrant here, because it's between 270 and 360. Okay, my dear students, it's our finish of our lesson for today. Until we meet again, from me, my pleasure and my greetings for you. Thank you. Goodbye.